All right. Last one is a logarithmic equation to go ahead and solve. So there's a couple different ways to solve logarithmic equations. Basically, when you have logarithms on both sides, you're either going to want to be looking into using the rules of logarithms or converting to an exponential equation. And some of them are going to use a calculator, some you're not. In this equation, I immediately see the one-to-one property, and hopefully you've covered the one-to-one property for exponents because it's fairly basic for exponents. Like if I had 2 to the x equals 2 to the third power, you could say, well, this makes sense. Like if 2 raised to what number is equal to 2 raised to the third power? Well, x is just going to equal 3, right? So when I have exponential equations with the same base raised to different powers and we want one variable, like we know those powers have to be the same. So that's the same thing with logarithms. Without going into the relationship of exponential equations and logarithms, I can just say, like, when I have a logarithm equal to a logarithm, and again, this only works when you have a logarithm equal to a logarithm, just like when we have an exponential equation equal to an exponent equal to an exponent with the same base. So these logarithms both have the same base because the base is e. So therefore, I can just rewrite the equation of 3/5 x plus 8 equals 1 minus x. So now I just need to go ahead and solve for x. So I'm going to add an x to both sides. So therefore, it would be 3/5 x plus 8 equals 1. And then I'll subtract the 8. Now, again, if I was going to rewrite, now again, remember this x has a coefficient of 1. So I can rewrite this as a 3/5 x plus a 5/5 x equals a 1 minus 8, which is a negative 7. Now, 3/5 plus 5/5 is 8/5. X equals a negative 7. And then you just multiply by the reciprocal, which is 5/8. 5/8. So therefore, x is going to equal a negative 35 over 8. Now, again, remember the domain of logarithmic equations is restricted, right? So if you have a logarithm graph, that looks like that. So we're going to want to make sure we plug this equation back into both of our equations and just make sure that it is not going to make our equation less than 0. Therefore, it would be extraneous. Well, obviously, if I had 1 minus a negative 35, then that would be that is going to be positive. And then when I multiply by 3/5 from this negative 35/5, that's going to be smaller than 8. So when I add 8, it's going to make it positive. So therefore, I'm working, and that is going to be my solution. So there you go, ladies and gentlemen.